Joining us now on Can Media is Wilson Pearce with ING Robotic Aviation. Thank you for your time today.
Thanks very much.
Robotic aviation, how does that apply to the oil industry?
Sure. Well, it applies in that we've looked at a lot of tasks it's called the 3D tasks: dull, dirty, and dangerous. Robotic aircraft first started off in the military, and we've got about 30,000 hours experience flying in the military, doing the dull, dirty, dangerous tasks, flying oversight, looking for IEDs, flying support for the Canadian naval ships. We realized that while the military technology was proven, there was an enormous commercial market to do the same kind of tasks. If you're doing, say, a pipeline survey, if you were doing a flare stack inspection, you're looking for equipment. You're trying to fly over large areas, and you don't want to put people up in aircraft if you don't have to. These aircraft are designed to operate at a much lower operating cost than a typical manned aircraft. A large helicopter that might burn 150 to 200 liters of fuel. You'll look at an aircraft like this one that you've got up here, runs half a liter of fuel an hour, and it'll fly for 8 hours. So, and they're fully autonomous vehicles.
So substantial cost savings here.
Substantial, yes, yeah. It's a reduced cost, reduced risk, reduced footprint story for us. The aircraft are all designed to be packed and moved out in a penguin case and moved off in an otter or a twin otter or a back of a pickup truck or something like that. And you're right, the small aircraft typically operate on battery, and then the larger aircraft, you're right, almost no fuel at all to keep them going.
So tell me, I mean, you've got pictures up here of flare stacks, you've got I see oil wells out in the ocean and pipelines as well. How exactly does it come into play when it comes to, say, monitoring a pipeline?
Well, from a monitoring standpoint, we can do a combination of things. We can fly a number of sensors on the aircraft. The most traditional sensors are EO, it's a daylight sensor, and IR, the thermal sensors. So you can run over and you can get visual imagery of your pipelines, and you can confirm incursions on the property line, you can confirm leaks. You may have had a false alarm go off on a pipeline somewhere. You can fly the aircraft out to determine whether you need to send a crew or not. One of the biggest risks in that traditional environment is you just send somebody out. He has no idea what he's flying into. Now he knows exactly what he's flying into. He's got the imagery. Through the data fusion work we're doing, we can also integrate our information with the information from other sensors, be they passive RFID sensors or other sensors, so you can get a very comprehensive view of what your technology challenge is.
And plus, like you're saying, well, you don't have to put anybody up in an aircraft. You also don't have to have somebody sitting by operating the drone while it's heading out to its location either.
That's correct. These are all fully autonomous. You plan in a waypoint on your computer system, and you tell it, launch, climb to this altitude, fly on this course, and when you need it, you then pick up the sensors and you operate the sensors. But you're right, it's fully autonomous, takeoff, landing. As I've said to a number of people, this is like an Airbus, but you've just dropped it down to 35 kilos.
Okay. Now, tell us a little bit. Let's talk about the three that you've got right here. Sure. So tell us a little bit about this one right here.
Sure. This is one of our smaller platforms. It's a quadcopter. It's called the X1. It was designed by the Danish. It was designed for the use by the Danish military and Danish special forces. It's what they call a person portable system. Now, the value to a person portable system is you can pick it up. Sorry about that. You can pick it up. It's completely light. You just pop it together like that, put it in a backpack, and you're off to the races. Yeah. And when you're ready to fly, it's that much to get it back out. So it's an incredibly simple system to operate and maintain. And it's the sort of system that you use. You want to throw it in your trunk. You got to get out there. You've got 30 minutes of operation. Fantastic high definition video and IR cameras. Okay. So that's your first one. You're moving around. You're throwing in the back of the car.
Great. What have we got over here?
This one here is called the Responder. We designed this one based on our experience in operating other sensors and aircraft where the sensor and the aircraft were very tightly integrated. So you had one aircraft and one sensor, and you really had no choice in what you were doing. What we've done here is we've designed a slightly heavier aircraft so it can withstand heavier wind conditions. This will fly under any general aviation condition. If you're putting a Cessna up, if you're putting a helicopter up, you can put this up. Okay. The real focus on this particular one is we've got a 10-kilometer range on it. So it has a command and control channel. It has a channel that manages the video, and then it's got a backup channel. We always have even though these are fully autonomous, they have 3 channels. The last channel is if you lose everything, you fly like an RC.
Okay.
So it's got multiple channels. They'll all communicate out over 10K. So you've got a 10-kilometer range for surveillance. And the what's really interesting is you've got a gimbaled system here that we've manufactured that allows multiple cameras. So if you've got your favorite camera, you want to put your favorite 35 mil on there, or we put a combined one that we built that's a dual daylight thermal camera. Mm-hmm. This will take any camera system.
Okay.
So that's one of the big advantages. We realized for these kinds of missions, these 30-minute missions where people are flying, people are going to have sensors we don't know anything about. So we shouldn't constrict them with our aircraft and prevent them from using that sensor. If you've got a sniffing sensor, an image sensor, what have you, we should be able to pop it on there. We were talking with somebody earlier today about what is effectively an RFID type sensor. Well, so we should be able to boost that and pick up the RFID signal from cattle. Or maybe you've got equipment out there in the field and you're trying to figure out where's my equipment. Well, we can fly and we can give you images of your equipment, and we can drop an RFID sensor down as well and tell you not only is that a truck, but it's truck equipment number 2610.
And like you were saying too, off camera with me a little bit earlier, something like this you would use to respond to, say, a potential emergency as well. If there's an oil spill, or you've got forest fire pictures up here as well, and you can send it up to look and see what the situation is.
Yeah, absolutely. Yeah, we named it the responder quite intentionally.
What are the price points for these guys?
Well, the smaller ones tend to run at around $45,000 to $60,000. As you get into the larger aircraft, you're looking at systems that go between $60,000 and $80,000. And then the fixed-wing aircraft up top, it's $200,000 bare bones, but it's $300,000 to $400,000 by the time you put all the sensors on board and your launch systems. And these are complete prices. You look at that, you've got the ground control station, the platforms, all of the computers, all of the systems. It's ready to go out of the box.
So you're just trying to get into with the oil industry and expand this market right now, aren't you?
That's correct. This is year one of entering into these commercial markets. These systems have typically been used in military applications and public security applications. There are some unique regulatory considerations that allow people to do that. We have a very good relationship with Transport Canada. They understand our experience. We're able to start entering into some commercial applications and commercial markets for that. So you're right, oil and gas is a fantastic area because you've got a lot of remote locations. You've got a lot of high-value fixed assets. You've got a very high cost to service a lot of those assets. And you've got a real risk of downtime. You can make a real business case for putting these things in because you're not risking the same kind of downtime or lost resources because no operations need to be shut down when you're overflying any of these areas.
Wilson, thank you very much for your time.
Oh, thanks so much. A pleasure.
We've been chatting with Wilson Pearce with ING Robotic Aviation.